Hey everyone, welcome back to The Explainer. I'm your host, and today, we are absolutely bringing the heat. You're stepping into what is essentially an authoritative masterclass, and it's explicitly designed to decode one of the most critical yet surprisingly misunderstood sections of your entire syllabus. We're talking about data verification during data entry. Specifically, we're zoning in on visual checks and double entry for the Cambridge AS and A-level computer science syllabus, code 9618. Look, if you've been banging your head against the wall trying to understand exactly how examiners assess this topic, or why you keep dropping random marks on these multi-step calculations, you are in exactly the right place. We're going to strip away all that confusion today and build a rock-solid step-by-step strategy so you can absolutely dominate this section of your exam. All right, let's get right to it. 15%. I want you to really let that sink in for a second. 15% is the sheer weight the topic of data verification carries in Paper 2 of the Cambridge 9618 exam. I mean, in the high-stakes context of an A-level examination, that's an absolute game changer, right? It's literally the difference between grade boundaries. It is the gap between a perfectly fine score and a truly exceptional one. If you can figure out how to effectively demonstrate your knowledge on just this single topic, you are securing a massive, massive chunk of your final grade. So yeah, the stakes are undeniably high. But the good news? The path to securing those marks is actually incredibly logical once you know exactly what the examiners are hunting for. Okay, let's dive into this. Here is our clear roadmap for securing those critical exam marks today. First up, we'll establish the core principles. Second, we'll break down the procedural framework. Third, we're going to uncover the method mark strategy. Fourth, we'll expose the top 3 examiner traps. And finally, we'll wrap the whole thing up with the ultimate exam framework: deconstruct, solve, evaluate.
Kicking things off with Section 1, Core Principles. And hey, before we get too deep into the academic benchmarks of the syllabus, a quick reminder to subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. All right, let's look at what the syllabus actually demands from you.
You know, the dividing line between average candidates and top-tier, high-scoring candidates sits exactly right here: superficial breadth versus analytical depth. Let's be real, knowing that a visual check is just a human looking at a physical receipt and comparing it to a digital screen, or that double entry is just typing a password twice so the computer can check if they match, that is superficial breadth. It's basic, and it simply won't get you those top marks. Top-performing candidates always, without fail, show a connected, conceptual understanding. They don't just know the what, they understand the why and the how. And crucially, they can take that conceptual understanding and transfer it to completely unfamiliar contexts. When the exam throws a wild curveball scenario at you that you've never seen before, you have to use analytical depth to apply the core principles of data verification to that specific, unique situation. So how do you actually achieve that analytical depth? Well, we need to look at how you're literally being graded. The assessment framework for this topic specifically targets 3 distinct cognitive domains. First up, knowledge and understanding. You've got to know the foundational definitions of verification, visual checks, and double entry code. Second, application. You have to take that baseline knowledge and seamlessly apply it to whatever weird and wonderful scenario is sitting there in the exam prompt. And third, analysis. This is the highest tier. This requires systematic, evidence-based reasoning. You basically have to break down the given data entry problem, analyze exactly why, say, a visual check might be super prone to human error in this one specific context, or maybe why double entry is safer but way too time-consuming, and then you build a rock-solid argument based on the actual system requirements. Which leads us perfectly into Section 2, the procedural framework. Because knowing the concepts in your head is only half the battle, right? Execution on paper is everything. Let's walk through the exact step-by-step methodology you need to tackle these complex questions. This 5-step progression is exactly how you prove your absolute mastery of the fundamentals to the examiner. Step 1, deconstruct the question. What's the command word here? What is the specific context? Step 2, extract relevant data. Pull out the constraints and system requirements hiding in the text. Step 3, select your analytical framework. Are you going to argue for a visual check, double entry, a mix of both? Set up your logical structure in your head first. Step 4, execute with clear notation. Look, if the question requires algorithmic thinking, you write it out so clearly that the examiner can follow your exact train of thought without guessing. And Step 5, present with correct terminology. Executing this exact sequence, it acts like a giant flashing sign to the examiner that says you are a highly prepared candidate completely in control of the material. Now, embedded right within that procedural framework is a highly specific skill. But what do examiners actually mean when they say data interpretation? Put simply, it means extracting data from representations, and hey, sometimes even binary representations depending on the scope of the question, performing the necessary calculations, and ultimately drawing hard evidence-based conclusions. Think about it. When a system uses a double entry verification check, it's essentially performing a logical comparison of two data streams. You must be able to interpret how that system processes the data, spot exactly where a discrepancy might pop up, and draw a conclusion on the reliability of that data based strictly on the evidence in the prompt. Nothing more, nothing less. Moving right along to Section 3, we have the method marks strategy. This is where we prioritize the process, not just the final answer. And hey, quick mid-explainer reminder, if you're finding this helpful, subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Let's talk about how to capture every single point. Here's a massive secret for the 9618 syllabus. Particularly for multi-step problems involving data verification, marks are heavily awarded for the process, not just whether you got the final answer right. If you just magically write down a final conclusion without showing the systematic steps you took to get there, you are leaving precious method marks on the table. To capture all of them, you have to satisfy the algorithmic thinking requirements. First, step-by-step decomposition. Break the data entry process down into its absolute smallest logical chunks. Second, appropriate data structure selection. Third, efficient code implementation, meaning if the question asks for pseudocode for a double entry check, your logic needs to be squeaky clean. And fourth, rigorous testing. By documenting these 4 elements, it's like you're leaving a trail of breadcrumbs for the examiner. Even if your final conclusion goes slightly off the rails at the end, executing these steps guarantees you capture the maximum possible method marks along the way. All right, let's shift the tone a bit for Section 4, Top 3 Examiner Traps. Consider this your strategic warning. We have analyzed the official principal examiner reports, and these are the most common, tragic student mistakes you absolutely need to avoid. Trap number 1, using the wrong algorithm for the context. You could write a truly beautiful, eloquent explanation of a visual check, but if the context was an automated, high-speed database processing thousands of records a second, a human visual check is obviously the wrong choice, 0 marks. Trap number 2, forgetting boundary conditions and edge cases. You have to ask yourself, what happens at the absolute limits of the accepted inputs? And trap number 3, which is honestly the deadliest one, generic answers lacking specific context. If the answer you wrote could be copy-pasted to apply to literally any data entry scenario on Earth, you are not going to get the marks for the specific scenario in front of you, period. I highly recommend creating a quick memory hack or acronym for yourself to remember these factors when you're in the hot seat. And this brilliantly illustrates the underlying issue behind so many of those traps. Quote, candidates consistently confuse key terminology. Always define terms before using them in extended responses. Guys, this is an official examiner alert directly from the source. Under the pressure of the exam clock, candidates constantly blur the lines between verification and validation, or they just vaguely talk about checking the data instead of explicitly naming it a visual check or a double entry verification. Don't do that. If you're writing an extended response, do yourself a favor and start by clearly defining the specific terminology you're about to use. It immediately establishes your authority and shows the examiner you know your stuff right out of the gate. Let's bring it all together now in Section 5, Deconstruct, Solve, Evaluate. This is your ultimate problem-solving loop for those tricky, higher-order assessment objectives. If you want to successfully evaluate alternatives and compare approaches, this is the exact sequence you need to execute. Step 1. Identify the given information. Step 2, break the problem into logical steps. That's your algorithmic decomposition we talked about. Step 3, solve it systematically. Step 4, check for reasonableness. Does your answer actually make sense in the real world? And Step 5, make justified recommendations. This right here is where you compare approaches. This is where you tell the examiner, look, while a visual check is cheaper, double entry is highly recommended here because the data is incredibly sensitive and requires 0 transcription errors. You evaluate, you compare, and you justify. That is the secret to unlocking the very top marks in Cambridge computer science. So the next time you finish a practice paper on data verification, I want you to look down at your page and ask yourself this one provocative question. Have you checked your boundary conditions and edge cases? Did you actually analyze the system to its absolute limits? Keep that question at the very front of your mind. It'll save you from the deadliest verification traps. All right, to keep mastering these frameworks with us, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Keep studying smart, keep applying that analytical depth, and I will catch you in the next explainer.